Hello, today we will discuss problem number 4 from quarterfinal from US Physics Olympiad year 2009 USAPHO. So problem. A certain electric battery is not quite ideal. It can be thought of as a perfect cell with a constant output voltage V0 connected in series to a resistance R small, but there is no way to remove this internal resistance from the battery. The battery is connected to big N ideal light bulbs in parallel. The bulbs each have a fixed resistance big R, independent of the current through them. Questions. Question A. Derive an expression for the total power dissipated by the N bulbs in terms of small r, big R, and V0. Question B. It is observed that the configuration dissipates more total power through the bulbs when N equals 5 than it does for any other value of N. In terms of big R, what range of values is possible for small r? Solution. For the first question, we can do next procedure. We know that power equal current square multiplied by resistance through which this current is going. So that will be this expression. This is the power through N resistors R, and R over N, that's total resistance for N parallel connected resistors. Next thing is to count what is current. Current equal total voltage V0 divided by total resistance, which is small r plus big R over N. And after that we can input this current here and find a solution for the first question. This is the result. Power equal V0 square multiplied by N big R divided by N small r plus big R squared. Question B. It is observed that the configuration dissipates more total power through the bulbs when N equals 5 than it does for any other values of N. In terms of R, what range of values is possible for R? Solution. We have this expression for power, and we know that for N equals 5, this value greater than when N equals 4 or N equals 6. So let's solve these numbers. So first we can solve this equation for this inequality when N equals 5 and here when N equals 4. We have this inequality. So we can first cancel R, make a square root from both parts and reverse it. So in that case we have this expression. So we have this inequality from this inequality. Now let's count what is a relation between small r and big R from this inequality. We have this inequality, and the last step is we can just multiply top and bottom by square root from 5 plus 2. In that case, on the bottom we have 1, and on the top we have a square root from 20. So it means that small r less than 1 over root 20 big R. Let's count what happened when N equals 6. We have this inequality. We do the same procedures here, and this is the result. When we cancel big R, we do square root from both parts and we reverse them. We have this inequality. After that we have this inequality, and multiply bottom and the top part by square root from 6 plus square root from 5. We will get this inequality. And the last step is to combine this and this. This is the result. So we have small r belong to this inequality. That's it. This is solution.